Welcome to the third doc tutorial in resolving DIDs. In the last tutorial we learned how to write a DID to the chain. However, DIDs are no good being written to the chain and not being able to read back. So we will need a way to resolve the DID in order to perform verification with them. DIDs can be resolved either by querying the doc chain, submitting a HTTP request to the Universal DID Resolver, or through a user-defined custom resolver class. To begin with, we'll need to define a few imports and connect to a node. However, this is only because we'll be writing a doc.did and querying from the chain. If you don't need direct chain access, you don't need to connect to a node and can just use a universal resolver or write in your own class, for example an Ethereum Resolver. Start with a base script like we have in other tutorials to connect to the node, and then taking some code from the DID creation tutorial, we will begin to define a method to write a DID to the chain again. Import some helper methods and define two variables, doc.did and keyseed. The write.did method will be called in main below connect to node. Okay, now if we run this code, it should successfully write a DID to our chain, and next up we should try to resolve it. There's two ways we can read a DID back from the doc chain, and the simplest way is to call the getDocument method of the doc.did module like so. Declare const document equals await doc.did.getDocument.did. This way can be useful if you need to resolve DIDs from the doc chain and don't need to interrupt with other areas of the SDK, such as credential and presentation verification. The preferred way is to define a DID resolver instance, as it has a common interface to get a DID document, and it can support multiple chains, and a fallback of the universal DID resolver. When resolving DIDs for the purposes of verification, the SDK expects a resolver instance. Let's define a method that we'll call the resolver's resolve method and to return a DID document. This method will take a resolver object and a DID string. Calling resolve will return the DID document as JSON. The first resolver we will use is called the doc resolver, and this class will take a doc API instance and read from the chain. Call in doc.did.getDocument internally. We can import doc resolver from @docnetwork/sdk/resolver, like so, and then define an asynchronous method named resolve.did with resolver that will take a DID argument, create a doc resolver instance, and then call the previously defined resolve method to output the DID document to console when we run the script. We can now update the main method to call resolve.did with resolver, passing doc.did. Running the code should write the DID and then output the document as read by the SDK to console. But what if the DID is not in the doc chain? We can't ensure that all credentials we want to verify or schemas we want to look up have the doc.dids on the chain. For that, we have a class named Universal Resolver. It is constructed with a URL that will point to a service, such as uniresolver.io, and on resolving it will submit a HTTP request to get the DID document. For interoperability, you can construct a Universal Resolver instance to resolve many different chain DIDs. So we can query for a DID in the connected node and to the Universal DID Resolver. But what if we want to do both and the node isn't on the Universal Resolver? Well, we can do that with the multi-resolver class. You can import it from the .network/sdk/resolver file, like the other resolvers. Once that is done, you can declare a method named resolve with multi-resolver with one argument DID. Within the body of that method, we are going to need to set up at least a doc resolver instance, a universal resolver fallback instance, and then finally instantiate and use the multi-resolver class. So, like before, we can create a doc and universal resolver. The multi-resolver class constructor takes two arguments, an object of DID type to resolver mappings. For example, DID:doc would map to doc::doc resolver, and so on. The second argument we should provide is a fallback resolver to use if no DID can be found in the mapping. Typically, you would supply a universal resolver instance here. And then finally, we add the resolve call, passing our multi-resolver. Calling resolve with multi-resolver with a DID, such as our variable doc.did, in our main method will return the document. You can also query some other external DIDs, such as this one from GitHub, which removes the need to keep referencing more than one resolver as we did previously in the tutorial. But what if the universal resolver doesn't support the DID that you want to resolve? For this, you will have to create a custom DID resolver class, and we enable you to do so by being able to import a base class called DID resolver. You can then extend it to suit your needs. So for this example, we're going to create an Ethereum Resolver. So create a new file named ether-resolver.js, where your DID resolving script is located, and then add the following. Here we import the DID Resolver base class that all resolvers should extend from, and we are naming our new class Ether Resolver, as it will be used to resolve Ether DIDs using the Ether DID Resolver npm package. Go ahead and install that package through npm install ether-did-resolver or yarn install ether-did-resolver. We have to provide some configuration options for this library when we initialize it, so let's define them at the top of our file with these imports. You can read more about the specifics of the configuration on the Ether-did Resolver GitHub or npm page, but for now we'll just use Inferrer to connect to the Ethereum mainnet. In our class constructor, add the following to initialize the Ether Resolver from the library, and update the resolve method to call it. The passDID method will take a DID URL and return an object with a fully qualified DID, the DID method, as well as the DID's ID. Not all resolvers need to call this, but the Ether Resolver requires it in this format. We should ensure correct error handling in custom resolvers so that tests and applications work as expected. To do so, you can import the noDID error class from docnetwork/sdk/util/DID and throw a new instance of it if the DID isn't found. Update the resolve method as follows. Like with other resolvers, we need to define a method that takes a DID URL, creates an Ether Resolver instance, and then calls the resolve function. You can call this in main along with your other resolver calls, and then try to run the script, and it should be successful. And this concludes the tutorial for the various types of DID resolvers in the Doc SDK.